how blockchain is being adopted across the industry and what it is exactly, what you need to know, basic 101 concepts like that. Alright? We have Prof. Sarah, who's going to be taking session 2, who's going to be more closer to bridging the gap between accounting and finance, and where you actually see the use cases being adopted. Session 3, we've got 2 demos for you of 2 live blockchain and cryptocurrency products. So we have Ian, who flew in from Singapore, and we have Dylan, who is working for a local crypto company called Conto. Both of them are going to be doing 2 product demos for you, and both of their tech is very closely related to accounting and blockchain. So some of you will be pretty interested in what they have to offer as well. Session 4 is again the panel discussion where Prof is going to, or Prof and all of us together, we will be taking your questions and whatever you need to know, right? So yeah, I'm going to be doing the more of the blockchain 101 sort of a session. So before I start, I'll give a quick introduction about myself and the firm I represent. Is called DNA, or Digital Nation Academy. So we are a software technology training institute that specializes in providing training specifically for blockchain, web programming, e-commerce, and a host of other industry 4.0 concepts. In your seats, you should have the brochure from us with all our current training offerings. So you can check that out, and in case at the end of this session, you're interested in subscribing to any of those trainings, you can register with us outside. If you have queries specific to the blockchain course offering, you can ask me as to what will be covered, what I need to be knowing, and things like that, right? So brief introduction about the firm I represent. We're a training academy. Now, let's start with the session, right? Google Trends. How many of you guys over here have heard or used Google Trends before? Trends.google.com. You're not sure, is it? Sometimes they use something. Yes. Alright. Anybody else? So what Google Trends does, for people who don't know, it shows you the number of people at a given point of time searching for a specific keyword on Google. Alright, and you know the number of users who use Google every second, right? Like this second there'll be millions of people using Google. So you can imagine the Google Trends to be a good visual representation of a particular interest in a subject. So I used trends.google.com. I went there and I typed in the keyword blockchain to gauge interest on how many people are interested in the word blockchain at a given point of time. Alright? So what you have here is sort of the interest in blockchain between January 2017 to December 2017. Alright? This was still 2 years back. So you can really see there was a huge hype cycle that started out for blockchain tech way back in January 2017 to an extent where it really peaked towards the end of the year. Alright, there were a lot of people interested in blockchain as a tech. Now, I have a question for you. Whenever you hear the keyword blockchain, what is another term that's commonly related to it?
It starts with B.
It starts with B and ends with N.
Yes.
Alright? Most people would not know blockchain if it weren't related to Bitcoin, right? So I decided to do one thing. I decided to compare, I decided to search for Bitcoin as well in this. And it looked something like this, with Bitcoin in red. So in 2017, at one point of time, there were literally like 100 times more people interested in Bitcoin than blockchain, right? Most of the attention that this whole technology got came from Bitcoin. And since then, since this 2017 upsurge that we saw, if you look into more recent times, you see that a lot of the hype and excitement that was once there has left. A lot of the hype and excitement has receded. This is to the end of last year, and it sort of closely follows this year as well. A lot of the excitement, hype, exuberance which people had about this technology has left. But that doesn't mean that it's not gaining any adoption. Alright, it means that there's actual people building solutions on this, like the 2 gentlemen out there who will be demoing their products. We've seen more real-world solutions emerge for this technology rather than a lot of the solutions that are driven by hype. So, anyone familiar with the Gartner hype cycle? Has anyone heard of it? Gartner hype cycle looks like this. I'm sure people working in tech might have seen it because it's very, very relevant to people in tech. Okay, nobody. That's fine. So, Gartner hype cycle is a sort of simple chart made by this company called Gartner, which represents all emerging tech in a graph like this, alright? what it denotes is in the x-axis or the flat axis, you have you're ranking against them against their amount of adoption obtained, meaning the more further down the line the tech is, the more closer you are to mass adoption. And it ranks that against the hype that technology is getting, hype or expectations or how many people are excited about it at a given point of time. So I don't think you can see, you have all these emerging technologies ranked over here: augmented reality, mixed reality, blockchain, visual assistance, IoT. So as you can see where blockchain is on the curve, it sort of perfectly matches the last two graphs I showed you. A lot of the hype and excitement behind this tech is already left. And we're in a stage where people are building actual products with it. We are in a stage where we actually need people with the skill to understand both cryptocurrencies and blockchain as a technology itself. Alright, so Gartner predicts that it's given by this dark navy blue circle, 5 to 10 years. In 5 to 10 years, this tech should have more mainstream adoption, and we're 5 to 10 years away from that. So that would make now a really, really great turning point to actually learn about cryptocurrencies, how they work, where they're used, to learn about blockchain technology, how it's implemented across industries. And probably this next 1 to 2 year phase is the best time to actually skill yourself with knowledge in these technologies. So for my session today, I'll just time myself because I don't want to, it's 2:20, right? So for my session today, I split my session into 3 basic categories: blockchain, what is it, why do we need it, and when do we need it. I'm going to specifically focus on what it is and why do we need it. Alright? When do we need it is a topic of discussion which is probably like a one-day training itself, because it's very specific as to when and how you can use it, whether you use crypto, whether you use blockchain. There's a lot of questions to be asked. I'll summarize it for you, but then it's a more elongated discussion. But for today, I'm going to talk about what it is and why do we need it. Before I start, is there anyone who's completely new to blockchain, or say how many people are like very new to blockchain, who knows less than 10 or 100? This is very hard. How many know something about blockchain, like more than 10 or 100? Okay, 2. That's pretty good. Alright, so why do we need it? Blockchain, and when you ask why do we need it, there's just 2 simple answers to it, alright? And for the next 20 minutes, you just need to keep this in mind as to when or as to why a blockchain is so useful in our community today. And these 2 things are intermediaries and inefficiencies, alright? And they're sort of a loop. In a way, one leads to another. I'll explain in the following slides what it is and how it actually plays a role. But just keep these 2 things in mind: intermediaries, number 1, and inefficiencies. I'll cover each of them separately. Intermediaries and centralization risks. So in our present world today, where we use services on the internet, where we use various other services to pay for items, we interact with a lot of businesses. Alright. So I was a freelancer back about 3 years ago, where I used to have a client in the US who used to remit money for me as and when I deliver a particular tech product. I was a coder back then. It was 3 years back. So back then, there was only one real service which actually provided a payment platform for global payments, and that was PayPal. So whenever I got a payment of something like 500 USD, PayPal used to take a fee of $75. That's more than 25% of what I earned. Alright, and more often than not, especially if you're working from a second world or third world country like India or Philippines, that's a huge portion of your income going in fees. But PayPal could do that because they have nearly zero competition, and they run an independent business, so they're obviously motivated to increase their business as much as possible. And so PayPal, Western Union sort of falls in the same category of companies providing a service and charging an extremely high fee, especially if that service is exclusive. Now there's a second category of centralized companies or companies in general, like Spotify or YouTube. We all know YouTube, right? We are all consumers of YouTube, isn't it? But one thing we often forget is there's an entire category of people who are producers of YouTube, content creators of YouTube, alright? And they are subject to whatever rules and regulations that YouTube sets for themselves. Content creators on YouTube often have to mend their ways or mend the way they upload videos, mend what type of videos they upload according to the rules set by YouTube, alright? So they are people who are really dependent on the decisions made by a company like YouTube because their livelihood's dependent on it. Alright, whatever the content they upload, they have to tweak it in a way that YouTube gives them maximum views. They are people who are completely controlled by the YouTube algorithm and what they've actually set for themselves. Right? So these are generally two types of intermediaries or intermediaries that you actually come in encounter with, especially in a lot of the internet connected services we use. We have companies like PayPal which provide a particular service, and there are entire ecosystems where people produce content, we consume them. YouTube makes ad revenue out of it, and they take like 40%, while content producers get 60% for doing all the hard work. So these are generally two types of brands we see out there. All right. So these are they're essentially organizations which sit in between a customer requesting a service and a producer providing a service. They sustain a business and charge a fee for brokering transactions in between customers and producers. And customers and service providers are subject to rules set by the intermediary with regards to their operation. So this is essentially how most of these companies operate. It won't be surprising to actually think 99.95% of the companies operate in such a model because they can afford to. The whole concept of decentralization has never kicked them yet, right? So this is where blockchain and distributed ledger technology actually comes in, where we want to move away from this paradigm where content producers on YouTube need not be restricted by the bounds YouTube has set, where we don't need to go for solutions like PayPal just because they provide the service of exclusivity. There are other means like cryptocurrencies which actually offer much cheaper means of doing the same remittance use case. Alright, so this is one section of companies. Companies providing a service or intermediaries, alright? There's an entire different ecosystem which I'm going to talk about with this example. Any of you familiar with how land titles or title ownership changes in most countries? Or essentially, most land titles, or say if I buy a house, they're all centrally recorded by one certain company called a title company in most cases, right? So a recorded title company, I'm going to oversimplify beyond imagination, okay? I want to keep this blockchain explanation perhaps the simplest and best one you would have received. You can actually tell me if I failed to do so, how well I achieved it. But I want to keep this explanation as simple as possible because I want everyone in the end of the session to at least describe to me in the most simplest of terms what a blockchain is and what it does. So I've kept this as simple as possible. So centralized scenario of title ownership. In a title company is solely responsible for tracking the movement of land title. So say I buy a house, that transaction would look something like this. And then every subsequent change in the transaction gets recorded by title companies in this following manner. So 1992, I had a failed inspection. I'm trying to sell my house in 2002. I don't want that record to be there because the moment people see it, I can actually, it's 2019. Like, there's always a way you can bribe someone and do something like this, isn't it? 2018 also gives you something else. It can let you write whatever you want if you have the right contacts to write, if you have the right strings to pull, you have means of doing this, right? You always have that some person to pay to actually amend records in such a favor. There are enormous scandals which have come out of purely the ability to do this in 2019. Fraud and tampering with data. Look no beyond than 1MDB to actually see this as an example. We've had huge cases for tampering of data by central authorities like this has actually come into play. Alright? So essentially, data when it's maintained by centralized or centralized custodians is tamperable. Make no mistake about that. But this is not the only risk which centralized intermediaries or companies in general have. Okay, there's a whole list of risks, and tampering is only one of them. It's always open to censorship or banning of participants. How many of us use Grab here? Or how many of us don't use Grab here? So if you talk to a Grab driver, I've at least talked to two of them. There are people who got banned from Grab. And just imagine. Alright. Okay. You guys can. Hello? Should I be holding the mic or not?
Sorry
For it to work?
about that. Because the live FB, somebody commented that can't hear you.
Ah.
So because since we're on live, it's better that your voice.
I can like stand here as well. Alright. So I'll just continue anyway. As I just hope this starts working all of a sudden. Alright. So essentially for banning of participants, you guys, if you talk to enough Grab drivers, you know that there are people who get banned out of the system all of a sudden for some particular violation that they may have. Alright, and Grab is not the only participant. YouTube occasionally bans content creators from because they would have uploaded some controversial content. So anything that goes close to gun violence, they would immediately slash that user, demonetize all his videos. This is a very grim reality, and not a lot of us knows about it because we don't often think about YouTube content creators. We consume content. We really don't think about the people making livelihoods out of YouTube. This is a very realistic scenario again. So censorship of users, alright? And this is actually prevalent in our industry. Rent seeking or charging high fee for use of a system, again look no beyond than PayPal. They have sort of an exclusive service of remittance, which is not that exclusive anymore, but they continue to charge a high fee. Even like last week, I had a payment coming in from the US. He chose to pay through PayPal, and I again ended up paying a good 15% fee. 15% in 2019 for something like remittance is too much. Just imagine you're getting a $100 wire coming in from the US, and if you're getting $85 at the end of it, that's a good portion of your income that is going. This is before taxes. I, as a foreigner in Malaysia, I have to pay 28% tax in the first 6 months. So you can just imagine how much the 15% matters to me in that case, right? Changing the rules of a system. So imagine YouTube's algorithm, right, for showing videos to users. It's constantly changing, and content creators are made to constantly catch up with that. They have to tweak their content in a way that they can actually win the YouTube algorithm and make sure that their videos get captured. So they sometimes will change the thumbnail, they'll have sometimes change the headings of the video just to make sure that you click on that. So this is again a grim reality where the producer has the platform has a lot of control on the kind of content that gets uploaded. Fraud or tampering with the data, like the example I showed you before, and susceptibility to central point of failures. This is more of a technical explanation, which I'm going to cover in a future slide. But in essentially, like in using a platform like this, in using platforms like PayPal, YouTube, Spotify, especially if you're making a living out of it, these 5 centralization risks do exist. And there is a real need in the ecosystem to actually have better decentralized means where one party doesn't have this huge control of the data that resides, right? And this is key moving forward. So this is talking about intermediaries and centralization risks. Like I said, there are 2 points. There's intermediaries and there's one more factor which answers the question why blockchain, and that was inefficiencies. Alright? So intermediaries acting in our ecosystem is one thing. But then mostly fed by the presence of intermediaries, there are a lot of inefficiencies that exist as well in a lot of the services connected on the internet or when businesses come together. So take the example of car ownership transfer of a particular vehicle. We have all these participants who play a factor in that entire life cycle. Alright? We have a manufacturer, we have a dealer, we have a leasing company, we have a leasee, and we have a scrap merchant. Alright? And they're all governed by a regulator who has to make sure that everything goes according to plan. So every company and this is not just leasing companies alone. There's a lot of industries where multiple people have to collaborate in order to achieve a goal, right? So each of these firms, they maintain their own copy of ledgers or databases or paper-based work and actually to track transactions between themselves. So they all have in-house ledgers or in-house databases which they have to maintain, alright? And as and when an ownership transfer happens, there's always a need for reconciliation. We call this name reconciliation. It's essentially checking whether all the data that exists in your database is the same. Especially in banking, if you think about it, whenever there's interbank transfers, it's really important for banks to identify that whatever you see in your database is the same as whatever you see in their database, right? So there's always a need for a reconciliation process. And reconciliation as a process can be extremely manual. It can involve people looking with the human eye to actually verify whether values they see here and there are the same. And that's essentially what accountants and auditors actually do. So there's a constant need for reconciliation of data, and this is designed in a manner that is usually being costly and expensive. Even with digitized solution, the most advanced digital solution we actually use is Excel, and that itself most of you would know is pretty manual. As in when your Excel spreadsheet have to be imported to somebody else, they also have to have a automatic. They also have to have a very manual process of checking whether all the values are correct and reconciled or not. So this is the major ideology behind inefficiencies. All right. So as a good example of this, look no beyond than traditional asset management. How many of you know the working of the trade life cycle of a stock, or actually have just read about it? It's an extremely complicated process. Is there anyone who's familiar with the trade life cycle of stock? I won't ask you to explain, don't worry. Anyone? So for an action as simple as buying a stock, it's an extremely complicated process. You have all these participants who play a role in that system. When I want to buy a stock, I have to call my broker to place a buy order on the stock exchange. Alright? My stock is actually owned by my custodian, and this order has to match with a seller who has the same participants as well. So this order should be matched by a clearinghouse, and the clearinghouse is responsible actually making sure the assets change hands. There's a lot of intermediaries, a lot of inefficiencies, to an extent where to sell a stock and get money out of it, it takes T plus 3 days, or 3 days from now. In most countries, in 95% of countries, it takes T plus 3 days to actually buy a stock and get money out of it, or to sell a stock and get money out of it. The US has moved to a model of T plus 2, but in most nations, it's extremely inefficient. In a blockchain or decentralized system, you won't have all these participants. You won't have so many intermediaries. You will have direct digital ownership of your asset, which you can go to a decentralized marketplace to actually switch hands. I'm going to go deeper into that in the next session. But this is the promise behind blockchain and distributed technologies, where you won't need to have all these intermediaries. You can have a decentralized network of participants who help you achieve that goal. All right? You won't have intermediaries who make you charge fees. So with that is my explanation of why blockchain, or why the need for decentralized technologies have emerged. Have I remotely answered that question, or is there still people who need to be convinced? It's okay, so everyone sort of gets it, or I don't know if I'm asking the question right, or whether you guys are tired from lunch. I'm not sure. It's all right, right? So you sort of know why a real need for blockchain and DLT has emerged. So let's get down to what it is. How many of you have small IT background, or like some knowledge in IT, like how technology works, a little bit? Oh man, nobody's raising hands. How many of you are not familiar with IT? Now I want everyone to raise hands. All right, so I don't know what the people who don't raise hands. All right, cool. So in, like, say, I'll take an example of CIMA clicks, right? When you use CIMA clicks or Maybank to you are using a client device, in this case your mobile phone, right? So this is called the client part of an IT system, where you interact with a website or your mobile app or whatever. All these interactions are directed to a server that resides somewhere usually within Malaysia. All right. So CIMA Clicks has their servers stored. I'm not sure if it's in Samantan or Cyberjaya, but one of those places has all the CIMA central infrastructure stored. Remember the fifth point I told you about centralization risk, central point of failure? That is a central point of failure. When you have all your data processing occurring in one geographic location. Alright? So this is how most IT systems are designed. They're all designed in this client-server architecture, where you have a lot of clients sending requests to a centralized server. Malaysia is even worse, because Malaysia is slower to adopt cloud technologies. Cloud technology is essentially saying that you can have your servers remotely running on, basically it's houses dedicated to hosting servers. But then Malaysia has a law saying that all servers, especially of government and banking, should exist within the geographic boundaries of Malaysia. So they can't actually reside outside. So it's actually a more step back. So Malaysian companies generally cannot adopt cloud solutions as fast. But the central gist being that you have centralized infrastructure running in one particular location. So typically structured around a particular infrastructure like this, you have ownership or access granted to a central group of administrators. Not everyone has access to their servers. It's usually the developers and administrators who are centrally responsible for managing the IT system. And finally, it's an architecture which is designed to create central point of failures. Alright, this is one that is hugely susceptible to centralization risk or centralized failures. So given all this rant about what I said about centralized technologies and why we actually need a blockchain or DLT, what is decentralizing on the other hand? What do we mean when you say decentralize a particular IT solution? And I think this is something really important to realize when you talk about decentralization or implementing a decentralized solution. Alright, decentralization has two parts. One is architectural decentralization and the other is political decentralization. Alright, it's not something very straightforward at all to do. When you say architectural decentralization, it means you are adding redundancy. You're actually multiplying your servers so that you don't have central point of failures. You have your servers stored in multiple locations so that it's not susceptible to a central point of failure. When you say political decentralization, it means you introduce more untrusted participants to actually maintain that network. You introduce more participants. There's a political element to it and there's a computer or hardware element to it. Decentralization is not a hardware thing alone where you just introduce more computers to maintain something. It's a political thing as well where you want multiple untrusted parties to be interacting in the system. You will understand much better when we actually talk about the example. But then to give you an extremely simple broken down example, remember the car ownership scenario I talked about? From this centralized scenario, when it moves to a decentralized solution, like I said, if you remember, you have manufacturers, dealers, leasing companies, leases and scrap merchants. They all work together and they all have their in-house ledgers, right? In a decentralized solution, what that looks like is you won't have a central data repository anymore. Every single merchant involved in that network will be running a computer system. Alright? They'll all send their updates across to one shared, they won't send their updates, but they'll all maintain a software which actually maintain this shared ledger between themselves. Alright, so in this case, we have architectural decentralization where every single party is responsible for maintaining their own computer systems and they record the same data. So in our case of land titles, it will be that common ledger of transactions. So this way, you're politically decentralized and architecturally decentralized, and that is what a decentralized solution must look like. It's not only hardware-related decentralization, but a political level decentralization as well. So blockchains are a means of implementing this type of decentralization, both a political and a hardware or architectural decentralization. But there's really one point key. Decentralization is a sort of term which is very often thrown around the tech space and it usually refers to architectural decentralization. The real key point to note is that blockchain is one of the 1,000 means to decentralize a particular IT system. Alright, there are many other solutions out there. You don't need to be using a blockchain in order to actually decentralize anything. Blockchain is a means of achieving both an architectural decentralization and a political decentralization. So what is blockchain? It's a collaborative technology. Remember the word, it is a collaborative technology. You cannot be a business owner. I'm sure I've always had somebody like this. You can't be like an individual business owner and say, how is blockchain going to influence my industry? Because you alone as a business owner have zero impact by blockchain. If you have an ecosystem of participants and you want to achieve a common goal, that's where blockchain as a tech actually plays a role. So blockchain is a collaborative technology for multiple untrusted parties to collaborate and share data. Alright? Are you guys able to follow thus far? It's all okay?
Yes.
Remember, collaborate, multiple untrusted parties to collaborate and share data. When I talk examples, you would understand much better. So let's talk about the example of land titles. What I showed you, remember the previous example I showed you? I'll show that how that looks like in a blockchain ledger or a decentralized ledger. Now trust me, if you understand this slide, you will know 75 to 80% of what blockchain is and how it works, alright? So all your attention, I would say even for the next 3.5 hours, try to give 10% on this slide, alright? 10% of your attention from the entire 3.5 hours, try to give it on this slide because you would probably understand most of what you need to know about blockchain. This is exactly how it works. Not exactly, I've oversimplified a lot, but you should get the gist of what it's about. blockchain network, remember I told you in a traditional system, you have a title company who is responsible for holding your title records. In this case, you have something fancy called a real estate blockchain. So a real estate blockchain is made out of a computer network of all the different participants who actually participate in the real estate ecosystem: buyer, seller, architects, everyone. They all maintain computer networks, and they're all connected by that common blockchain software running between themselves. Alright? So that loosely what you could, I'm just giving you an example, but this is how a real estate blockchain would look like. You can have similar examples with banking blockchain. You can have like a lot of ecosystem forms like this. So in a real estate blockchain, when I want to sign a transaction, say this is the first transaction, this is the first item of a block of data that's going in. In such a blockchain, the person who's writing the transaction, alright, the person who's writing the transaction will be given something called a cryptographic key. Alright, this is a digital key, and this key is unique to the person writing the transaction. Nobody else actually has access to it. Nobody is supposed to be having access to it. If somebody else has access to it, it means that there are like two of these people, but ideally nobody should have access to this key other than the person writing the transaction. Alright, it's called a cryptographic key. So with this key, what he can do is sign this bit of data, and when he produces his signature, you have to think about it really simply. Don't dig deep into too hard. When you produce a signature, it's something we have something called a unique signature, which is created called a hash, which is a unique string of random numbers and variables and sequences. Alright, it's a unique sequence of alphabets, and this is a unique key which is produced by this block of data. If you change anything even mildly from this key will change entirely. And this signature is unique to this key. Everyone sort of gets that, right? So with this key, you can produce a unique string of data. Now, when the next person wants to write, say this, so remember, this is written into a blockchain ledger. That means this piece of data is replicated to every participant in that system. Alright, so this data replicates across the whole network. Everyone can see all the data that's written and the signature that was associated with that data. When the next person wants to write, you have an owner, alright? The owner also has a key which is unique to him. When this is how blockchains are secure. Okay, so make sure you pay attention to this bit of detail. When he signs a block of data, he's going to create a signature out of not only his chunk of data in 1980, he's going to take the previous signature as well. So it looks like this. Alright? So as you can see, every transaction that goes on a blockchain ledger is backlinked to a previous transaction as well. Right? So he produced this bit of data with this key, but he took the previous signature as well. So likewise, when the next participant comes, the architect, he wants to sign a transaction with a key, he will take this signature and write the next block of data. So you sort of see how this is secure. If you imagine all the transaction that correspondingly goes to a blockchain ledger is linked to the previous key. So every transaction or every block of data that's written in a blockchain is associated by something that's previously written on it. The thing is, this is super secure because this block of data resides not only in one central system, it resides in the entire network. It's replicated across the entire network. And this is super secure because the moment somebody tries to change anything over here, this signature will show a mismatch. And every other signature won't match anymore. So the moment somebody tries to do it or somebody tries to push that bit of data, everyone will know that somebody's trying to play with the system. So you can't actually monkey the system so easily. And that's why blockchains are so secure. Because of this backlinking that exists, it will be easy to identify anyone who's trying to play around with the system. So blockchain ledgers are decentralized by means that they're replicated across the system and they're kept secure like this by following this means. Alright? So with that in mind, blockchain and DLTs have four basic elements. Alright? Loosely, blockchain, DLTs, and cryptocurrencies as well. So in the previous example, so one of the basic elements of blockchains are peer-to-peer networks. Alright? When you have multiple untrusted parties like in a real estate blockchain coming together to actually form a network, it's called a peer-to-peer network in computer science. You have a network of participants trying to achieve a common goal. Whenever I use the term key keys and signatures and hashes and all that, it loosely falls under the category in computer science called cryptography. And this is a key element of blockchains and distributed ledger technologies. You have consensus algorithms which also come into play. Remember, this blockchain ledger is a piece of software which is run by multiple participants. When they run that software, they're automatically connected across this network. So in this software, we have a consensus algorithm running which tells the blockchain this transaction is right, this transaction is not. So there's a form of consensus being reached by every participant in that network as to what is right and what is wrong to be written. Alright? So these three are the keys, the core elements of blockchains. Alright? Now we should ask ourselves, so how is all this related to cryptocurrencies? Alright? So there's a fourth element, but the fourth element only applies to cryptocurrencies. It's called incentive models. Alright? And incentive models are fundamentally how you differentiate blockchains from cryptocurrencies. This is how both of them are completely wide apart. Blockchains do not have an incentive model in place. Alright? Cryptocurrencies include all four. You've all heard of Bitcoin, right? So, in a cryptocurrency blockchain network, there is one major feature which is lagging in a traditional, say, a private blockchain setup between a certain group of companies. In a cryptocurrency blockchain network, every participant in that system is incentivized to be a part of that system to secure that network. Meaning every time you confirm a transaction or every time a block of data is written in a cryptocurrency blockchain network, you get some amount of Bitcoin for actually doing so. In this in the crypto space, you call these people miners. Miners are people in the Bitcoin network who actually confirm transactions and write them into the blockchain, and whenever they do so, they get some amount of Bitcoin in return. Meaning they are people who are incentivized to participate and create that cryptocurrency network such that they're secure. Alright? So these are the four key elements. Traditional blockchains don't have this element. Say a blockchain network formed by a group of banks. Banks don't give out any incentive rewards for people who actually run their network because they're trying to achieve a common objective. There's no need to really give out any incentive. Cryptocurrencies are different in the sense that they are open networks which anybody can join, and if you join, you are given incentive to be a part of that network. You're given incentive because you're securing that network. So everyone should understand there are four key elements. Cryptocurrencies have four key elements. They have an incentive model attached to it. While traditional blockchains used privately between certain businesses, certain organizations, they have three. Alright? So this is the simple breakdown of blockchains, distributed ledgers, how they're different from cryptocurrencies. So there are a lot of use cases. It's difficult to enumerate a lot of the use cases that happen today. So we have a lot of private business networks between banks together forming a blockchain, and that's very common. You have digital currencies, which are again an application of blockchain technology. So the most popular ones being Bitcoin, Ethereum. And how many of us over here trade Bitcoin or once used to trade Bitcoin? Anyone over here? Anyone who's bought a Bitcoin? Okay. Anyone who's heard of Ethereum or other blockchains? Okay, you guys are going to learn a lot today from the people taking the demo. So their demos are more focused on cryptocurrency and really makes sense for accountants to actually understand that. So digital currencies are one highlight use cases of blockchain. You have digital assets being represented on a blockchain, cars, stocks. You have a lot of companies who are moving in that direction. And the central theme of today's topic, accounting. And you have Prof who will be talking more on that subject. Alright? So, given all this, now you know why blockchain and what it is. When do we need it? Is blockchain applicable for every potential use case that you can imagine? Plain dead answer I can give you is no. It's a solution to a very, very specific problem, and that solution really requires a lot of analysis, and it's not something that you can decide yes or no at the point of time. Right? So when do we need it is again a very use case specific question that you should be asking yourself. Whether you actually work in an ecosystem which actually needs a blockchain. So let's look at, I've summarized loosely what are the type of use cases which needs a blockchain. So let's look at this list below. So number one question you should ask yourself is when you say, is there a problem of centralized risk and inefficiencies? So the slide I talked about centralization, risk and inefficiencies, you should really ask yourself whether you work in an ecosystem, whether that has any of those problems. Alright? when blockchain, this is perhaps the number one question you should be asking yourself. Do you actually suffer from those issues cited before? Would your solution work better on a database? I really wish more companies would have asked themselves this question, because more often than not, whatever solution you are actually thinking which you're building towards a blockchain solution could have been done on a database as well. So remember, there was a huge hype cycle back in 2017 where a lot of companies were running into blockchain and creating solutions out of it. 95% of them don't exist today because they were building a solution for a problem that didn't really exist or could have been easily solved by databases. So this is again a key point that you should be analyzing, whether the need for a blockchain can be solved by using traditional technologies that already exist today, databases, cloud. If some of you are familiar, we have something called Amazon Web Services, cloud services, or traditional servers. More often than not, you might be working in an ecosystem where you don't really need a blockchain. But this is again something that you should be analyzing. Is there an absence of trust among the participants? Say you identify the perfect use case for blockchain. You know who your participants are. Key question to ask is there absence of trust between them? Say you're saying that you want to implement blockchain in your organization. If it's your organization, then why is there a real need for a blockchain? You could just do everything on a database, right? So again, this makes sense to be asked, and a good example, like I told you, would have been the asset management use case. There were so many custodians, so many untrusted parties working together. A blockchain is more suited for something like that. Number 4, is the solution cost effective to build? This is again a very key important question if you consider the fact that most of these firms who decide to work together, they'll all be working on a different technology stack. Most of the time, their technology stack is not going to be compatible. They'll always have some of them will be using mainframe, some of them will be using Linux, Ubuntu, or many other different types of distros, right? More often than not, their tech might not be compatible with each other. So this is something that really needs to be analyzed, because more often than not, what we've seen blockchain solutions might be expensive to build because of this particular fact. Number 5, who are the validators in the network? Say you identified your use case, who is going to be responsible for confirming transactions? Who will be responsible for participating in the consensus of the network? And number 6, what does your end decentralized application look like? What is your goal you're trying to achieve by bringing people together to actually achieve this common goal, right? So these are 6 common questions you should ask yourself when you're approaching blockchain. The entire realm of cryptocurrencies are quite different. So cryptocurrencies in general are being used for payments as an alternative means to support traditional methods of payments that we have, that is through banking and cash. So these questions don't really apply here. But then we'll have a future session where the speakers of our demo are going to be covering that. In the next slide, what I want to show you is like a 9-minute video of showing the applicability of blockchain in 19 different industries. You can actually have a look and sort of get a feel about what the industry is headed towards, or what types of solutions are being built using blockchain. It's a pretty comprehensive video. So yeah, let's start.
The blockchain is one of the most promising new technologies for the future. So what is it? It's a distributed ledger technology that underlies cryptocurrencies like Bitcoin and provides a way to record and transfer data that is transparent, safe, auditable, and resistant to outages. The blockchain has the ability to make the organizations that use it transparent, democratic, decentralized, efficient, and secure. The blockchain is likely to disrupt many industries in the coming 5 to 10 years.
And many banks like Barclays are also working on adopting blockchain technology to make their business operations faster, more efficient, increasingly investing in blockchain projects and startups. IBM predicts that about 15% of banks will be using the blockchain by the end of 2017.
Number 2, cybersecurity. Although the blockchain ledger is public, the data is verified and encrypted using advanced cryptography. This way, the data is less prone to being hacked or changed without authorization. The blockchain eliminates the need for middlemen, making it more efficient than many legacy systems in cybersecurity.
Number 3, supply chain management. With blockchain technology, transactions can be documented in a permanent decentralized record and monitored securely and transparently. This can greatly reduce time delays and human mistakes. It can also be used to monitor costs, labor, and even waste and emissions at every point in the supply chain. This has serious implications for understanding and controlling the real environmental impact of products. The blockchain can also be used to verify the authenticity or fair trade status of products by tracking them from their origin. Some blockchain startups working in this sector are Providence, Fluent, SkuChain, and BlockVerify.
Number 4. Forecasting. Blockchain is set to change the entire approach to research, consulting, analysis, and forecasting. Online platforms like Augur are looking to create global decentralized prediction markets. These technologies can be used to place and monitor bets on anything from sports to stocks to elections in a decentralized way.
Number 5. Networking and Internet of Things. Samsung and IBM are using blockchain technology for a new concept called Adept, which will create a centralized network of IoT devices. Operating like a public ledger for a large number of devices, it would eliminate the need for a central location to handle communications between them. The devices would be able to communicate to each other directly to update software, manage bugs, and monitor energy usage.
Number 6. Insurance. The global insurance market is based on trust management. Blockchain is a new way of managing trust and can be used to verify many types of data in insurance contracts, like the insured person's identity. So-called oracles can be used to integrate real-world data with blockchain smart contracts. This technology is very useful for any types of insurance that relies on real-world data, for example, crop insurance. Eternity is one blockchain project that is building tools that are useful in the insurance industry.
Number 7. Private transport and ride sharing. The blockchain can be used to create decentralized versions of peer-to-peer ride-sharing apps, allowing both car owners and users to arrange terms and conditions in a secure way without third-party providers. Startups working in this area include Arcade City and Lazus. The use of built-in e-wallets can allow for car owners to automatically pay for parking, highway tolls, and electricity top-ups to their vehicle. UBS, ZF, and Energy are some of the startups developing blockchain-based e-wallets.
Number 8. Cloud storage. Data on a centralized server is inherently vulnerable to hacking, data loss, or human error. Using blockchain technology allows cloud storage to be more secure and robust against attacks. Storage is one example of a cloud storage network using blockchain technology.
Number 9. Charity. Common complaints in the charity space include inefficiency and corruption, which prevent money from reaching those who are meant to have it. Using blockchain technology to track donations can let you be sure that your money is going to end up in the right hands. Bitcoin-based charities like BitGive Foundation use blockchain's secure and transparent distributed ledger to let donors see that the intended parties receive the funds.
Number 10. Voting. Probably one of the most important areas of society that blockchain will disrupt is voting. The 2016 US election is not the first time certain parties were accused of rigging election results. Blockchain technology can be used for voter registration and identity verification, and electronic vote counting to ensure that only legitimate votes are counted and no votes are changed or removed. Creating an immutable, publicly viewable ledger of recorded votes would be a massive step forward in making elections more fair and democratic. Democracy Earth and Follow My Vote are two startups aiming to disrupt democracy itself through creating blockchain-based online voting systems for governments.
Number 11. Government. Government systems are often slow and opaque and prone to corruption. Implementing blockchain-based systems can significantly reduce bureaucracy and increase security, efficiency, and transparency of government operations. Dubai, for example, is aiming to put its government documents on the blockchain by 2020.
Number 12. Public benefits. The public benefits system is another sector that suffers from slowness and bureaucracy. Blockchain technology can help assess, verify, and distribute welfare or unemployment benefits in a much more streamlined and secure way. GovCoin is a UK-based company that is helping the government to distribute public benefits using blockchain technology. The blockchain is also a good contender for implementing a basic income. Circles is a project working on developing a blockchain-based technology for implementing a universal basic income.
Number 13. Healthcare. Another industry that relies on so many legacy systems and is ripe for disruption is healthcare. One of the challenges hospitals face is the lack of a secure platform to store and share data. They're also often victims of hacking because of outdated infrastructure. Blockchain technology can allow hospitals to safely store data like medical records and share it with the authorized professionals or patients. This will improve data security and can even help improve accuracy and speed of diagnosis. Gem and Tyrion are two startups that are working on disrupting the current healthcare data space.
Number 14, energy management. Energy management has been a highly centralized industry for a long time. Energy producers and users cannot buy it directly from each other and have to go through the public grid or a trusted private intermediary. Transactive Grid is a startup using the Ethereum blockchain that allows customers to buy and sell energy directly from each other in a peer-to-peer way.
Number 15, online music. Several blockchain startups are coming up with ways for musicians to get paid directly from their fans without giving up large percentages of sales to platforms or record companies. Smart contracts can also be used to automatically solve licensing issues and better catalog songs with their respective creators. Mycelia and Ujo Music are two startups creating blockchain-based solutions in the music industry.
Number 16, retail. When you shop, you trust the retail system of the store or the marketplace. Decentralized blockchain-based retail utilities work differently. They connect buyers and sellers without a middleman and associated fees. Sorry, Amazon. In these cases, trust comes from smart contract systems, the security of exchanges, and built-in reputation management systems. Two startups disrupting the retail space are OpenBazaar and OB1.
Number 17, real estate. Some of the issues in buying and selling real estate are bureaucracy, lack of transparency, fraud, and mistakes in public records. Using blockchain technology can speed up transactions by reducing the need for paper-based record keeping. It can also help with tracking, verifying ownership, ensuring accuracy of documents, and transferring property deeds. Ubiquity is a blockchain-secured platform for real estate record keeping that is an alternative for legacy paper-based systems.
Number 18, crowdfunding. Crowdfunding has become a popular method of fundraising for new startups and projects in recent years. Crowdfunding platforms exist to create trust between project creators and supporters, but they also charge high fees. In blockchain-based crowdfunding, trust is created through smart contracts and online reputation systems, which removes the need for a middleman. New projects can raise funds by releasing their own tokens that represent value and can later be exchanged for products, services, or cash. Many blockchain projects have now raised millions of dollars through such token sales. Although it's still early days and the regulatory future of blockchain-based crowdfunding is uncertain, it's an area that holds a lot of promise.
Number 19, your industry.
I think loosely that's about it. So remember, this video covered a lot of use cases with respect to using blockchain in a particular or different types of industries, right? You should keep in mind that cryptocurrency is an entire different realm. So whenever they talked about tokens or using blockchain for payments, most of them is closely linked to using a particular cryptocurrency, meaning a cryptocurrency which is run in a decentralized manner, not your typical Malaysian ringgit or anything like that. So we have the two demos which are loosely going to be based on cryptocurrency in our industry. So how should I put it? The cryptocurrency space in Malaysia is something again that's quickly emerging. Very recently, the Securities Commission approved 3 exchanges to actually start operating in Malaysia, meaning you can now legally buy Bitcoin, and this is going to really drive adoption in this space. So it was an industry which was shut down back in 2017 when the SC came out with a ruling that exchange operators cannot operate in Malaysia anymore. So this is again a very positive ruling that's come into play, meaning like exchanges can now start legally operating again, and we're going to see a lot of adoption in the cryptocurrency space as well. So I think with that, that's about it. I'm open to questions for the next 5 to 10 minutes or so before Prof. Sarah takes this session. So anybody who has questions on Blockchain 101 or any specific technical questions regarding the subject I described, you can ask it now or during the panel discussion that we have following all the sessions.